Good morning. This is the video for another video for AP Calculus section 2.3. We're doing two things, the quotient rule, and also we're going to learn the other trig derivatives. I'm going to stand up real quick so my lights don't turn off any second, which I bet they would have had I not done that. Sorry about that. So let me remind you that last video was the product rule, and you really do need to commit to memory that the product rule is the first times the derivative of the second plus the second times the derivative of the first. That really needs to be automatic when a function is a product of two functions. Today we're talking about the quotient. So here's the quotient. It's another phrase you need to memorize, absolutely need to memorize. Obviously on your assignments and your tests for me in the craziness of the current world, you can have it in front of you. But the AP test, you won't have it in front of you. So here we go. Okay, here it is. The derivative of f over g, f divided by g, that's a quotient, is, and this is the phrase you need to know. It is the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. I feel like I need to say that again, and I've said that 4 bazillion times in my teaching career. The quotient rule, the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. And there it is in variables. The derivative of f over g, it's gf prime minus fg prime over g squared. Just as welcome to memorize that. Again, it's so stuck in my head. The bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. I bolded or I capitalized the minus sign. Remember, the product rule has a plus sign between the two terms, and there's no fraction, but the quotient rule has a minus sign. So let's try a couple examples of using the quotient rule. So let's take the derivative of 5x minus 2 over x squared plus 1. There I wrote the quotient rule right there for us. So these derivatives can get pretty ugly pretty quickly, and you have to be, just like with the product rule, the question is going to be, how simplified do I make it? So we'll either take out a common factor, combine like terms, or we'll see. So here we go. This is the bottom, which is x squared plus 1, times the derivative of the top. The derivative of 5x minus 2 is just 5, minus the top, which is 5x minus 2. Uh-oh. Sorry, let me fix that. Fix my lousy handwriting. 5x minus 2 times the derivative of the bottom, which is just 2x. Just hoping I can squeeze it in there. All over the bottom squared. The bottom squared is x squared plus 1 squared. Now, very common to clean this up. We're going to clean that numerator up. The denominator, we're not going to, sorry, I'm trying to erase that, but put a better exponent there. The bottom, we are not going to write that twice and FOIL it with itself. We're just going to leave it as x squared plus 1, the quantity squared. But that numerator, I can distribute a 5 and also distribute a 2x and really carefully distribute this minus sign. Got to be real careful. It's easy to do some algebra wrong here. So if I distribute a 5, I get 5x squared plus 5. And now I have 5x times 2x is 10x squared is going to be minus 10x squared. And I have 2x times 2, which is 4x. It's minus 4x, but then there's a minus sign out front, so really it's minus negative 4x. I think it's plus 4x. All over x squared plus 1 squared. And now I might just combine like terms. What's that? Negative 5x squared plus 4x plus 5, I believe, all over the quantity x squared plus 1 squared. Done. There's a derivative of that. Using the quotient rule. Bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Next example, I have some options here. I could use the quotient rule. Clearly, that function is a quotient. Or I can recognize, I could divide all those terms, rewrite the function first. And actually, a problem just like this showed up on your last test where you didn't know the quotient rule, so you had to rewrite it first. I think in general, it's going to be easier to rewrite it, but I'm going to do this both ways and see if we can't get the same answer. I will say that sometimes same answers might look different. They could be equivalent forms. So first, let's, in fact, quotient rule this. So this is f of x. I may need to do the rewriting on another slide. I may need the whole width of this slide to make this fit. So let's quotient rule this. This is the bottom, which is x squared, times the derivative of the top. The derivative of that numerator is 12x to the third minus 14x. Bottom times the derivative of the top minus the top, which is the whole 3x to the fourth minus 7x squared plus 9 times the derivative of the bottom, which is 2x. All over the bottom squared. And the bottom squared is x squared squared. All right, now let's clean this up. A lot of these just have lots of algebra. So I'm going to really carefully distribute an x squared. And I'm going to distribute this 2x. And I'm also going to be aware that there's a minus sign between them. I'm going to be real careful distributing that. So distributing my x squared here, this is 12x to the fifth. What's it, minus 14x cubed. All right. Now I'm distributing a 2x to the minus sign, so that is minus 6x to the fifth. And then I have minus 14, no, it becomes plus 14x to the third. And then minus 18x. Now the bottom is x squared. I multiply exponents, I get x to the fourth. Let's keep going. I could combine like terms. I think 12x to the fifth minus 6x to the fifth is 6x to the fifth. Ooh, I have minus 14x to the third plus 14x to the third. They agree to go away. That's kind of nice. And then what? Just minus 18x over x to the fourth. I would argue I clean this up. I could take an x out of the top. If I factor an x out of the top, I get 6x to the fourth minus 18 over x to the fourth. And if I cancel one of the x's, I get 6x to the fourth minus 18 over x to the third. I might call that a reasonable place to stop. Quotient rule, nothing wrong with it. But I also might want to rewrite this function and then just take it piece by piece. I think we're going to find it's going to be easier. So let me rewrite this on the next slide. If I can fit, so I'm going to have to go back and forth here. So I'm just dividing each term of my original function by x squared. So 3x to the fourth over x squared is just 3x squared. I'm just rewriting my function. This is 3x squared. And then minus 7. Oh, 7x squared over x squared. That's just minus 7. That's nice. And then the next one, I've got 9 over x squared. I'm going to write that as plus 9x to the negative second. Plus 9x to the negative second. That is my function. That is not my derivative. Something looks different. I hope I don't have a typo somewhere. Hold on. Picture keeps getting away. Oh, I do have a typo somewhere. Ruh-roh. I apologize for that. I'm getting a different answer here. Oh no, I'm not. I lied. The form looked different. So let's take the derivative of this. This is an easy derivative to take. It is 6x, 7 goes away, and I have what, minus 18x to the negative third, which I could write as 6x minus 18 over x cubed. Notice this form and compare it to this form. If I divide both of those by x to the third, I absolutely get 6x minus 18 over x cubed. So either way is fine. The moral of that story is be aware of, is there a way to rewrite the function to make it an easier derivative to take. And there often is. Okay. Now, I just said something important, but I'm going to almost contradict myself. Be aware of rewriting it to not have to use the quotient rule. So this next slide has more examples. It says one more example. If the denominator is a constant, it will always be easier to rewrite it before taking the derivative. I could quotient rule that, but I'm telling you that since it's just a number, let's write this as y equals 1/3 times 4x squared minus 7, because that's what it means to divide something by 3. And now let's rewrite this as 4/3 x squared minus 7/3. And now let's just take the derivative of this. The derivative of this is the derivative is y prime. What's that? 8/3 x. Like, that's it. Would have taken you longer to quotient rule that. You could quotient rule it, but it's not as easy. Now, I just said if it's easily simplifiable, make it not a quotient rule. Here's what I don't think you should do. If it's x plus 7 over x minus 2, I'm telling you to use the quotient rule. Like that's a perfect quotient rule. You might think, what if I wrote it like this? X plus 7 times x minus 2, the negative first. That is true that's what that equals. And you might think now I could product rule it. It is not easier to do that. So don't avoid the quotient rule by making it an uglier product. But if you can simplify it, if it's just dividing by 3, like the last example, or just dividing by x squared, where each piece was easily divided, then it's worth avoiding the quotient rule. Okay. Last thing in this video is the trig derivatives. And we already know the derivative of sine and cosine. If y equals sine, the derivative of y is cosine of x. And if y is cosine, the derivative is negative sine. Now, I'm not going to go through proving these other ones, but tangent is just sine over cosine. So I could use the quotient rule to find it, but that's how they did it. And we have the conclusion. So we have conclusions for all of these. These, again, ultimately, absolutely must be memorized. So the derivative of the secant of x the derivative of the tangent x is secant squared of x. I really don't need those parentheses, sorry. And let me remind you that is equivalent to the secant of x squared. Like that's what that notation means. So that's the derivative of tangent is secant squared. The derivative of cosecant is negative cosecant x cotangent x. Again, the derivative of cosecant is negative cosecant cotangent. Again, just use them enough, get comfortable. The derivative of the secant of x is the secant of x times the tangent of x. Because the derivative of the secant of x is secant of x tangent of x. And lastly, the derivative of the cotangent of x is negative cosecant squared of x, which again could be rewritten as negative cosecant of x squared. You'll never see that notation, but it's equivalent. So some of your assignment uses those. You have to go back and reference those since you're seeing them for the first time. But there you have it. Quotient rule, other trig derivatives. Your assignment is not a short one. My picture's in the way again. Again, I mentioned this yesterday. I have to pick up the pace in this class. So your product rule assignment is due tonight, I believe. I am going to sometime this weekend make a video of some of the odd ones for both product rule and quotient rule. I have to say that I may post some of those answer videos after they're due. I need you to know that it's not about turning it in correctly. It's about being able to check your work to make sure you know what's going on. We're reaching the point where we're going to start going faster. If you just do stuff and you don't care whether it's right, just move on to the next stuff, this will snowball and get pretty ugly pretty quickly, and trying to avoid that. So whatever your effort has been in this class so far, I'm telling you, it's got to kick up a notch. So I'm going to go a notch faster to get where I'm going. So there it is. 7 to 12, 15, 16, 18, 20. You don't need to read me those numbers. There they are. And it's due Monday. So that is not the end of 2-3. There's one more video for 2-3. That'll probably post Monday morning. Then we're done with 2-3. The next quiz will be on 2-3 and 2-4. I'm hoping it's coming up pretty quickly. 2-4 is a pretty important one also, so we'll get to that. So that's it. Have a great Friday. See ya.